Hi guys, our mini lesson today is going to be about hazardous chemicals. We're going to deal primarily with flammable and combustible liquids. I thought you might like to have the quiz up front. Again, it's okay to have it with you while we're going through the presentation, so hopefully you can get these answers right. We're going to be talking about the differences between flammable and combustible. There's some terminology like flash point we'll be dealing with, which one's above 100, which one is below. We're going to talk about different types of ignition sources, how to safely handle, store, and dispose of the chemicals, as well as how safety data sheets play a role in this. I'll also show you the quiz at the end as well. It's important to know that the two primary hazards that you have to be concerned about when dealing with these liquids are going to be explosion and fire. And OSHA has quite a few rules dealing with the safe storage and handling of these types of liquids. Flash point, this is the temperature that a chemical gives off ignitable vapor. So if you have something that is, say, an ignitable vapor or its flash point is at 50 degrees, and your environment right now is at 0 degrees, it can't give off ignitable vapor and therefore won't burn. Flammable liquids have a flash point below 100 degrees Fahrenheit. Combustibles have a flash point above 100 degrees Fahrenheit, at or above. That's the difference between the two. It's 100 degrees Fahrenheit. Typically, because our environment is cooler than 100 degrees, flammables are considered a little bit more dangerous to deal with. Interesting here that gasoline is a negative 45 Fahrenheit for a flash point. So, like I said before, let's say you have gasoline and you're in the Arctic and it's 60 below zero. It's not going to give off ignitable vapor and won't burn. The program that OSHA is going to outline or that you have to have for your company is going to be looking at ignition sources, how to control those, how to store the chemicals safely, if there is any sort of fire, or to mitigate it, what type of fire control is in place, as well as the safe handling. Okay. One of the primary things they need to look at is what types of ignition sources are in the environment where these chemicals are going to be used or stored. And a real big one is static electricity. It's one of those things that we don't typically see and don't think of. Whenever you're transferring a liquid through a pipe or even through an opening, static electricity is generated. And whenever that is generated, um, it's a positive charge. And whenever it comes in contact with ground, that's when you'll get that arc, that spark, and that would be an ignition source. So static electricity is something that needs to be looked at very closely, and there are ways to be able to minimize the problem. Bonding and grounding with the containers, that's what we're going to be looking at. So if you're going to transfer a liquid from one tank to another, because of the charge between the tanks, you need to have them equal. So if you connect a wire, okay, something that can transfer electricity, from one tank to the other, you've now bonded the two. They will be at the same charge. The problem now is the ground. The ground is at a different charge. So you also have to ground with a wire or something that will conduct electricity. One of those tanks or part of that system has to be grounded. So both bonding and grounding are important. Ventilation is also very important because you need to be able to get vapors away from any ignition sources. When you're storing, you have to look at the different types of chemicals that you might have. Some don't get along very well, they're incompatible. So they're going to look at quantities, where they're being stored, how incompatible they are, and that's going to usually be dealt with by distance. maybe separate buildings, the types of containers, that sort of idea. Okay. Wherever you're going to be storing these, they typically can't be like in a basement where there's going to be traffic above it. It might compromise an exit route if these catch on fire. Okay, they're going to be using safe storage containers, so like flammable cabinets, metal safety cans, as well as with a disposal side as well. Here's an example of a safety can. They're usually metal, they're vented, the lids will close on their own, so they're spring loaded. They'll also allow for pressure that builds up in the can to be able to be released. The safety cans also have a spark arrestor or a flame arrestor inside. And this is a type of a mesh cone that is in the spout. And if flame were to be able to get in there, it will actually use up all of the vapor and put the flame out. Flammable safety cabinets or storage cabinets. These are insulated. They must be grounded. And also, if there are going to be fumes inside, they have to be vented to the outside. We'll look at these more this summer. When it comes to fire control, again, you need to know what type of chemicals you're dealing with and what type of fire devices need to be used to mitigate spread of fire if it does happen. All of these things that we've been talking about can be found on the safety data sheet. So remember, every chemical has its own safety data sheet, and it will tell you how to deal with fire, how to safely store the chemical, safely handle the chemical, and the safety data sheet will tell you what its flash point is. That way you know if you're dealing with a flammable or a combustible. So transferring a flammable liquid needs to be done through either a closed piping system or using safety cans. If it's a gravity system, you have to have a self-closing faucet, and there are safety pumps that can be used as well. Here's some examples. This is a gravity-fed drum that's using a faucet to go into a can, so this is probably a fuel can. That valve will close automatically if you let go of it. There's a ground wire going from the drum somewhere to a suitable ground. And here's an example of a bond wire. They're bonding the drum to the can. Safety pumps would be the same idea. So this is a can, it's a closed system. It can be wheeled around wherever it's needed. But again, whenever you're transferring the liquid, because coming through that hose into the can generates static electricity. So again, they're going to bond the two together, and there's a ground wire going off to a suitable ground. Disposing of these chemicals. You've got to use approved containers here as well. You guys have all seen the oily waste rag can here that we have in the shop. Remember, any sort of a rag that is chemically soiled or chemically saturated cannot go directly into the trash. It has to go into one of these safety containers so that if it does reach a point where it can spontaneously combust, it won't burn the house down or burn the building down. Okay. When it comes to safe handling, you've got to know, again, what you have for a chemical, read the labels, look at the safety data sheet so you understand what you're dealing with. Good housekeeping is very important. If you ever have any spills, clean them up immediately. Remember, you're probably dealing with ignitable vapor. You need to clean the source up right away. Use approved containers. Keep containers closed when you're not using them. Also, like the flammable cabinet, close it when it's not being accessed. Only use flammable liquids when you have enough ventilation, and keep the stuff away from ignition sources. Remember, the two primary hazards are explosion and fire. You can find out a chemical's flash point or how to safely handle it by looking at its safety data sheet. And that sums up the presentation for today. I am going to show you that quiz one more time. I'll leave it up here for a few more seconds. Don't forget to get these questions answered and send them to me on the Remind app or email them. Either way. And I'll see you guys on Wednesday, again at 1 o'clock for our Google Meet. Have a good one.